All right, so now we're going to visualize fractions. This is kind of a long video, and it's just because there's just so much with fractions. It wouldn't hurt my feelings at all if you don't sit and watch the entire thing, or if you speed this up to do like a speed of ×2 or something. It just because I feel like if you're in this class, you probably already have a relatively good grasp of fractions. But if this is something that is new for you, you might want to sit and go through these problems and watch me work them, and then you work them yourself and see if you can do it the same and all that good stuff. So just understand that these videos are not something that I expect you to go home and take very serious notes on. I really just want to remind you or get your brain thinking of these things that you probably already know. All right, so fractions are a way to represent parts of a whole. And so in this pie right here, that shaded region, I'm just looking at just this one on the right. I have 2 pieces out of 3 shaded, so that would be 2/3. Now on the one on the left, all of them are shaded, so that would be 3/3, which is the same thing as 1. That whole pie is shaded. So if you put these together, I have 1 and 2/3 of a pie. And just a reminder, the top number is called the numerator, the bottom number is called the denominator, and I always remember denominator as being the bottom because I think of demons. It kind of has that word, that feeling of that word, and demons are in hell. So anyways, that's how I usually remember denominator. They're in the bottom. All right, so this page, again, just a reminder page. And also, a big deal for fractions, your denominator is never ever allowed to be 0, ever. It creates issues, it causes things that are undefined, so just make sure that your denominator is never ever 0. Okay, so just so you know, no matter how many pieces the pie is cut into, if all of them are shaded, you have one entire pie. So in this case right here, we've got 6 out of 6 that are shaded. Anytime you have all of them shaded, that is equal to 1. If it were cut into 7 pieces, you'd have 7 out of 7, that's 1. If you had 10 pieces, that's 10 out of 10, you'd have 1 whole pie. And so just so you know, any number divided by itself is 1. And remember, we can't have 0 pieces of a pie. Even if you have one pie and you don't cut it into any pieces, that's still 1. You can't say, I'm going to cut it into 0 slices. That's still 1 slice, even if you don't cut it at all, okay? All right, so whenever you're cutting up pizzas, if you want to eat half the pizza, then you can eat just that one big piece, either side of that. Or if you wanted to cut it into smaller pieces, then you could cut it into maybe 8 slices and take 4 of those. That's still half the pie. 4/8 is the same thing as 1/2. Other equivalent fractions would be maybe 3/6 or 5 out of 10. So just a number that represents half. The number on bottom represents how many pieces you cut it into. So the equivalent fractions property just says that if you have a fraction, and we'll say we have 2/5, that if we multiply the top, and I'm just picking a random number out of the air, I'm going to pick out 4. If I multiply the top and the bottom by that same number, then I'm actually not changing the value of this fraction at all. I'm just changing the number of pieces that it got cut into. 2 times 4 is 8. 5 times 4 is 20. So 2/5 is the same thing as 8/20. So equivalent fractions can be made by multiplying top and bottom by the same non-zero number. Okay, so now we're going to find 3 fractions that are equivalent to 2/5. So let's say I'm going to pick -1. 2 times negative 1 is negative 2. 5 times negative 1 is negative 5. That's equivalent, okay? Because a negative divided by a negative is a positive, all right? So negative 2 over negative 5 is equivalent to positive 2 over positive 5. All right, so let's find another one. 2/5, and I'm just going to pick another random number, 10. So 2 times 10 is 20. 5 times 10 is 50. So here's another one that's equivalent. So far I found 2 of them. I'm going to pick another random number. 2/5 times, let's say, 8. 2 times 8 is 16. 5 times 8 is 40. Here's another equivalent fraction. Every person in our class could have different answers on a problem like this, and it's okay. Whenever you create those equivalent fractions, those fractions that you created are not simplified. If you were to simplify them, you'd go back to your original problem or your original fraction. So just so you know, whenever we created, let's see here, 16 over 40, that is not simplified. But if I divided the top by 8 and the bottom by 8, look what you get. You come up with 2/5, okay? So you simplify fractions down to their lowest form. I do want to warn you, from here on out, you truly, anytime I tell you to give me an answer and that answer is in fractional form, I expect your answer to be simplified. Unless I'm asking you for equivalent fractions, which then you don't need to simplify. Otherwise, if you have just an answer in a fractional form, it has to be simplified always. Okay, so here we have negative 32 over 56. And by the way, that negative sign is assigned either to the top or to the bottom. It's not assigned to both. Okay, so in this problem, let's say that I don't see that 4 will go into both of those. I see that they're both even, so I'm like, okay. I'm going to divide top and bottom by 2. And then I look at that and I think to myself, well, those are both even as well. Maybe I could divide both of those by 2 again. So this would be negative 8 over, oh, well, look at that. Now both of those are also even, so I can keep dividing by 2. There we go. Now both of those, they don't have any common factors. So here is the simplified form. So what I could have done is in the very beginning, I could have divided both the top and the bottom by 8, which would have gotten me there a heck of a lot quicker. But sometimes that happens. Sometimes you don't see that you could divide by 8 quickly. So sometimes you have to just keep dividing by 2. Just keep on going until you get it to the lowest possible form. When I tell you to simplify, I expect the lowest possible form of that fraction. Okay, on this problem right here, I look at both of those and I see that they're both at least divisible by 5. So I'm going to divide. Okay, so I'm going to divide the top and the bottom by 5. And whenever I divide the top by 5, I get negative 42. And the bottom, whenever I divide it by 5, I get 77. Okay, so now I need to ask myself, are there any numbers that can go into 42 and 77? And what comes to my mind immediately, like with 77, is I know that it has factors of 11 and 7. Well, I know 11 won't go into 42, but 7 will. So I'm going to divide top and bottom by 7. And there we go. Now that's our fully reduced form. Now what that means is I could have divided both of these numbers by 35 and come up with the answer quicker. But I don't always see it quickly. By the way, you are allowed to simplify fractions with a calculator. There's nothing wrong with that. So get some practice with that. all you have to do is type in the fraction and hit enter, and it will give you the simplified form. If when you type in the fraction to a calculator and it spits out the same answer that you just typed in, that means it's not simplifiable at all. Is that even a word? I'm not sure, but it can't be simplified. Okay, so on this one, I just put the same problem on here because I wanted to point out some buttons to you on the calculator. Hopefully you're using a calculator that's like this. And so this one's a little hard to read because it's a little blurry, but if you were to simplify this, now the calculator doesn't like to simplify negative numbers. I'm pretty sure I don't have one sitting in front of me, so I can't really check. But what I would do is I would just realize that my answer is negative on this problem. And I would type in the 210. So I would hit this button here. So hit, wait, this is off a little bit. 210. Then hit your fraction button, which is right here. It says ABC, and then hit your 385, and then hit the enter or the equal button at the bottom, and it will give you the correct answer. So I just want to point out your fraction button is right here, ABC. And like I said, just type it in, hit enter, and it will give you a fraction. Now, the fractions on these calculators aren't very pretty, but once you understand what you're reading, it makes it really nice to use. Okay, so with algebra, you can't type into a calculator the x and the y. But what you can do is you can look at the term itself. So 5 times x over 5 times y. You are allowed to mark out like factors. And in this case, our like factors are the 5s. 5 divided by 5 is 1. So what I'm left with is x divided by y. So this is a reminder of what fraction multiplication is. With fractions, you just multiply straight across. So if your numerators are, let's say we have the fraction 2/5 times 1/3. You would do 2 times 1, multiply your numerators, multiply your denominators. And you're done. Reduce if you can, but in this case we can't. So we are finished at 2/15. Okay, so again, this is just a picture of a calculator, so I can't actually push the buttons and show you what you would do, but I can help you out with typing it in. So if I were using this right here, I'm using this problem right here. Notice how there are no variables in the problem. So you want to type this in just like you see it, okay? You cannot type the variables into this calculator. So if you have a problem with variables, you have to leave them off. All right, so the first thing you would do, your negative is right here. So type in negative, then you would hit 11, 1, 1, then hit your fraction button, which is right here, and then type in 12, 1, 2. Then hit your multiplication button, then you would hit 5, hit your fraction button, 7, and enter. Okay, so whenever you do that by hand, though, again, you can multiply straight across. Negative 11 times 5 is negative 55. 12 times 7 is 84. And that's what you should get on your calculator. So this problem right here, notice how there are variables in this problem. So when you're typing in this into the calculator, you type in this, hit your multiplication for the parentheses, or you can use parentheses if you want. Open parenthesis is right here above the 8. Close parenthesis is over here right above the 9. But the thing that you are not allowed to type in, you're not allowed to type in that x. But you can do the other parts on the calculator. So you would type in negative 12, hit your fraction button, and then 5, times negative 20, and then enter. Okay, but if you're doing this by hand, this is the same thing, negative 12 over 5 times negative 20x over 1. And remember, you can reduce before you multiply. So in this case, I would reduce diagonally. Whoops, wrong page. I would reduce diagonally, so the 5's, or I'm sorry, this 5 goes in there one time, and the 20, 5 will go into 20 4 times. So now what I'm actually multiplying is I'm multiplying negative 12 times negative 4x over 1 times 1. Negative times a negative is a positive. So I get 48x as my answer. Okay, I'm going to use this word often in this class, reciprocal. Reciprocal just means that you flip the fraction over. So if you have like 1 and 2/3 and you want the reciprocal of that, the first thing you have to do is turn it into an improper fraction. 3 times 1 is 3, 3 plus 2 is 5. So 1 and 2/3 is the same thing as 5/3. But the reciprocal is 3/5. So first I had to turn it into an improper, then I had to flip it over. With fraction division, you keep the first fraction the same. Notice it's the same right there. You change the sign from division to multiplication, and you multiply by the reciprocal. So you flip over the second one. So I always say keep, change, flip. All right, so with fraction division, keep the first one, change your sign to multiplication, flip your second one. So now just multiply straight across. Negative 2 times 5 over 3 times n. So I get negative 10 over 3n. All right, so the little calculator popped back up again. And this one is a good problem to use on the calculator because it doesn't have any variables in it. Remember, you can't type the variables into the calculator. But you can also do this by hand. Negative 7/8, change your sign to multiplication, flip your second one. And again, I would reduce the 7 and the 14 before I multiplied. You can reduce diagonally or you can reduce vertically, but you cannot reduce left and right. So now the 8 and the 27, there's nothing I could do there. So now I just multiply straight across. Negative 1 times negative 27 is positive 27. 8 times 2 is 16. Now I will tell you this. If you type this into the calculator, you're not going to get 27 over 16. And the reason why you're not going to get that is because this calculator automatically turns it into mixed numbers. 16 will go into 27 one time with, 11 left over? So these two answers are the same answer. The calculator will give you this one. Honestly, I prefer this one because with the improper fraction, you can add, subtract, multiply, and divide. With a mixed number, you can only add and subtract. So I do like impropers better. As long as they're reduced to lowest term, improper is actually a great way to leave it. The term complex fraction just means that it is a fraction within a fraction. So it does look complex. It looks messy. But if you just remember that a fraction bar means divide, then we can turn complex fractions into things that aren't so complex. So look at this hot mess right here. So numerator is 3/4, so I'm going to write it like this. This fraction bar right here means divide. 5/8 is our denominator. So again, whoops, keep, change, flip. Keep the first one, change your sign to multiplication, flip your second one. I reduced the 4 and the 8, and now I'm going to multiply straight across. 3 times 2 over 1 times 5, which is 6 over 5. If you were to type this into the calculator, it wouldn't give you 6 over 5. It would give you 1 and 1/5, which those are the same, and I would accept them for full credit on a test. But just know they are the same, though. And I like this one better, but I would not take off points for 1 and 1/5. So this is a complex fraction that I would not type into the calculator. You have x over 2 divided by xy over 6. Keep your first one, change your sign to multiplication, flip your second one. And what I want you guys to realize here is that because these x's are the same, those can get divided out. The 2 and the 6 can be reduced, and now you multiply straight across. And there's your final answer. So simplifying expressions with a fraction bar, just 2 steps here. Simplify the expression in the numerator, simplify the expression in the denominator, and then you simplify that fraction at the very end. Alright, so check this out. What you want to do is follow your order of operations. A fraction bar is considered a grouping symbol. So that's just like having parentheses there and there. You don't usually see them written, but they are understood to be there. So you want to reduce what you can in the numerator, reduce what you can in the denominator by following the order of operations. So the numerator, I would do this part first, right here, this 2 times 3. Okay, so I've got 4 minus 6 over, and in the denominator I have to do the 2 squared part first. So 4 plus 2. The numerator, I can reduce that. 4 minus 6, negative 2. 4 plus 2 is 6. That is not a good answer because it's not fully reduced. You always simplify your answers, and so you should get negative 1/3 as an answer here. Now, if you were typing this problem into the calculator, you do have to type in those parentheses. So you have to type in parenthesis 4 minus 2. You can do another parenthesis, but notice I have one closed parenthesis and I have an open parenthesis that doesn't have a closed parenthesis. So you have to put another closed parenthesis there. Then you can hit divide button. Then you would hit 2 squared plus 2. But notice I don't have parentheses on the bottom. So all the numerator would get divided by is this right here. That's bad. So make sure you have those parentheses in the denominator too. So put parentheses around the entire numerator, put parentheses around the entire denominator. Okay, I'm just letting you know where the negative sign is allowed to go. It is allowed to go either the numerator or the denominator or just off to the side like in the last part right here. But just know there is only one negative sign in this problem. 2 negative signs make it a whole different number. It makes it a positive number. Alright, so this problem right here, again, if you're typing it into the calculator, you would have to do that. Alright? Okay, so here's what I would do first if I were doing this by hand. I would go ahead and multiply 4 times negative 3, and I would go ahead and multiply 6 times negative 2. So I would be left with negative 12 plus negative 12, and again, just to make it look cleaner, I would put those parentheses around that second negative 12. In the denominator, I'm going to go ahead and multiply those guys, negative 6 minus 2. And now I'm going to simplify the numerator. I get negative 24. Negative 6 minus 2 is negative 8. And now I simplify that fraction. Negative 24 divided by negative 8 is positive 3. On this problem, I'm going to translate the English phrase into an algebraic expression. The quotient, remember quotient means divide, of the difference of m and n and p. So I want the difference of m and n and I want the quotient of that and p. And if you want to put parentheses around the numerator, you can. In this case, because this fraction bar is long enough, it does imply that there are parentheses in the numerator. All right, that's it for this lesson. So if you have any questions, please let me know.